I'm not talking about photo or photo products. I'm going to talk about data, something I love. I actually am crazy about data. I've been doing this for a very long time. I have a bunch of little stories and hopefully some lessons that you guys can take away. Liz was helping me with this talk, and part of what she had said was, in talking about your examples, can't you just tell them the answer? And I can't, because the things that I've had to go through, the systems that I've had to build, the problems and challenges that I've faced don't exist anymore in many cases. That they're, figuring out how to distribute data across multiple machines on a back-end database that has hundreds of millions of records, like that, you don't have to do that anymore. You just go to AWS, you go to Google, they just take care of it. But that didn't exist. We actually had to figure out, how do you take something that is massive, that will no longer fit on big iron, or you can't afford the big iron anymore. How do you distribute that? So a lot of these things are more, how do you think about the problems as they pertain to data, and less about what is the right answer. So in terms of data is dead, long live data, so the king is dead, long live the king. The idea is there's a lot about data that is dead, that doesn't matter anymore, and you have to think about it differently. So hopefully that's what we're gonna get. I wanted to start with a quick exercise. And just to help you understand a little bit about data, how I think about things, so there may be 25 people in the room. If you don't want to participate in this, that's fine, you don't have to. I'm just going to ask relative how old you are, your age. So if you don't want to let anybody know how old you are, you don't have to raise your hand. But just so it's fair and equal and open, I'm 54 years old. I was born in 1962. So anybody over 80 in the room, hold your hand up. Okay, nobody. Anybody over, I'm just going to jump to 60. Anybody? Okay, nobody. Anybody over 50? Okay, keep your hand up. Okay. Anybody? Yeah, you're not. Anybody over 40? You can put your hand up now. Okay. Anybody over 30? Keep your hand up if you've had to raise it. You're going to have to keep it up here a second. Anybody over 20? Okay. Anybody over 10? Over 0? Okay. And those of you who didn't raise your hand, that's okay. That's actually really interesting data, or the converse. The absence of data is actually really interesting. I guessed, and was talking with Liz last night, that I suspected that the average age in the room, this was last night, I didn't know how many people there would be, I didn't know who would be here, would be in around 30, somewhere between 27 to 30. If you think about who was raising their hands and how they were raising their hands, and if we then reversed that and said, okay, if you're under 10, if you're under 20, we would kind of go back the other way. It's interesting just to see, what can you get from that? What kind of insights can you get from a seemingly random population? I know this isn't random, it's definitely skewed, but there's data in everything we do, and we can observe those sorts of things. The other thing that we can notice is, I think there are only 3 women in the room. So if you think about 4 women in the room, there is a distribution of data that usually we don't think about. You walk out on the streets, it's whatever it is, 51%, 49%, I think is what they say biologically. So something there. So then a little bit of data about me. So I love data. This is intentionally obtuse. This is essentially a CSV version of my CV. It's probably a little bit difficult to read, but there's the start year and the end year. There's the company name, the location, and the positions. And as data, this isn't very interesting. Looking at data itself isn't interesting to me at all. It's what I can do with it. It's the questions I can ask, the insights that I can get from that. So if we think about it, this is actually something you're probably more familiar with. This is information. It now has the ability for people to understand it. But what's really interesting about this is there's actually new metadata in this that's very different than what was there before. So here we actually see now in reverse chronological order the companies I worked for, the title I had. This doesn't say where it was, but it tells you, oh, it can calculate something. Oh, I was in this position for 1 year and 6 months, where the prior data set didn't have that. Here we can see the company icon, Zynga, then Technorati, and then, oh, well, Postini doesn't have an icon, Neo Mio doesn't have an icon, Venus Sports doesn't have an icon, Excite doesn't, oh, Electronic Arts, that has an icon, Oracle, that has an icon. I'm speculating, I don't really know, but I believe it's because those 4 companies don't exist anymore. So those icons don't exist on LinkedIn. Nobody ever bothered. All the other companies still exist. Technorati is Technorati Media, but it's still some subdivision of some company. So again, now we've taken the original core data that was just in a CSV, and we've been able to present it in a different way, marry it with some additional data, an image URL, and interestingly, something else emerged. And again, it's not actually the data that was interesting to me, it was the absence of data. It's the fact that those don't have images. Like, why? What is it? I think I'm right. I think it's because those, well, one, nobody ever tagged the image, but I think also those companies don't exist anymore. So what does it all mean? I think to really understand the meaning of data, you have to take your own context and your own experience and apply it to that data. My career data, that CSV by itself, isn't very interesting. And I would think if you had that in your own data file, you could look at it and you could each derive different insights from that. I think I held 4 different jobs at 4 different companies in the year 2000. Like, what was that? Was I just job hopping? Well, it turned out I was working for companies that kept going under because the dot-com bubble was bursting and we couldn't get any funding. I finally found one, and that one lasted, but then we were acquired a year later. There's an arc to my titles from just database administrator, software engineer, manager of MIS, manager of engineering, director of engineering, VP of engineering, database administrator. Oh, what the hell happened there? It's like, well, I went from a big company to a little company. It was 10 people. I didn't care about title. They weren't going to give me a title. I just became a database administrator again. I was quickly VP of engineering, but it was a way of, you can look at that data and think about, well, what stories can you get from this? So I love finding the stories in data. There's this notion of sort of the misuse, the abuse, and the use, hopefully proper use, of data. And I'm going to tell you some stories around that where hopefully some of these will help you see how people pretend that data is actually information. It's not. Data is just data. That CSV file isn't there. You have to add something to it. That storing data for data's sake, a common expression I've heard lots of people say way too many times, is storage is cheap. Well, it is and it isn't. At the end of the day, storage becomes really, really expensive, and I'll show you some stories about that, or tell you some, and then hopefully some happier stories about where did data and data analytics actually make things work better. So here's the first one, Oracle Sun Microsystems, 25 years ago. I was working at Oracle. Oracle is a sales-driven company. Larry Ellison is a chief salesman. It's all about revenue, revenue, revenue. Everything's about revenue. They're crazy about revenue. The marketing team really wanted to be able to prove their value. And they thought they had an amazing campaign, quarter-end campaign for the Sun Microsystems version of the RDBMS kernel. And it was a 30% discount. It was going to be amazing. Well, guess what? At the end of the quarter, sales on Sun Microsystems went through the roof. More orders, more revenue, marketing high fives all around. Everybody was stoked. I happened to be working with the guy that had to do the next level of detailed analysis. And what he found is there were actually a small number of salespeople who sold very large orders on the Sun Microsystems platform at a 20% discount. Anybody here ever been an Oracle customer? Anybody here ever think like, well, Oracle's going to give me a 30% discount, but no, I'm not going to take that. I'm only going to take a 20% discount. Of course not. Nobody would do that. It turned out these salespeople actually, in order to maximize their commissions and hit their quarter-end targets, were able to subdue the knowledge of this marketing program to those customers to make sure that they get the 20% discount so the customer would feel good about it. They would get a bigger commission because the dollar value after the discount was bigger. So it was just complete abuse. But on the marketing team side, it was really just the misuse. They didn't think about the data and the correlations that just because the number of orders is up and just because the sum total of all revenue is up, on the specific platform that you targeted, you should also then look at what's the distribution of the discounts that people got. And the fact that there were a number of very large deals at a 20% discount when you were giving 30% off tells you those people didn't know anything about your marketing program. Your marketing program either failed or what was much more likely is the, the salespeople made sure nobody heard about it. Mafia Wars. So I was the CTO on Mafia Wars for a year and a half. Mafia Wars was a Facebook social game. We grew rapidly. Things were crazy. We had a very successful run with the game. I was responsible for the infrastructure, the engineering team, working with the product people on a lot of that. We had, unbeknownst to us, a massive problem with bots. So people that would write JavaScript bots that could play the game automatically, which was against our terms of service. And one day, we pushed a brand new release of the game, new game of the code. Our servers, we had a giant server array. Let's say we had a server array of 500 different servers serving up the game. We're running at between 65 to 85% utilization. On that class of server, at 85% utilization, you're just seconds away from falling over. So we were redlining most of the time. We push this release, server utilization drops to 30%. All of a sudden, we have this extra headroom. We're just like, whoosh, no, the servers are chill. Everything's fine. PMs are freaking out. Everybody's looking at every last bit of information that we could find. Revenue's not changing. Number of concurrent users, that's the number of people playing in that second, no change. Number of transactions per second on the web servers, not really changing. Like, what on earth just happened? Well, it turned out that we had pushed a new version of JavaScript out that broke the bots. What was really interesting is over about the next 4.5 hours, the server load went back up to where it was. Because the people who wrote the bots, the JavaScript, found the bugs, fixed the bugs, and it took about 4.5 hours for that to propagate to all the people that they had shared. Those bots represented less than 6% of our unique player IDs, but 30 percentage points of our server load. So over half of our server capacity, this is 500 servers, this wasn't cheap, was dedicated to 6%, less than 6% of our player base. So again, it's important to understand the distributions, it's important to understand the correlations. We actually realized it didn't matter. It didn't hurt anything. The bots weren't paying us anyway. So it was fine for us, but again, we looked for everything. The initial thought was, oh my God, what did we just break? And I'm really glad we chose not to roll the release back. We said, let's just press on. Let's figure out what actually matters. And it turned out nothing really mattered. It was just bots. That then also informed me, because I was responsible for the cost side of things, to think, how do I start controlling bots? Because they're abusing our systems, forcing us to double our infrastructure costs, and they don't pay any money. So it turned into a whole different story. I have some nice little emoji bucket here. Manual testing of mobile games. This is 6 years ago. About 6 years ago, iOS represented about 90% of the market for social gaming revenue. All in-app purchase stuff was all on iOS. Android was starting to grow, but nobody could figure out how to monetize it. Not that many people were using tablets. Interestingly, people who use tablets tended to spend more. So people on tablets, iPad, were actually more valuable, but there weren't as many. Being Zynga, it was all about just push, push, push for the biggest audience, the fastest buck, the easiest way to do things, which isn't always a bad business model. But we had 100 mobile testers. We specifically chose not to automate or develop any automation testing frameworks. And as we launched more and more product, we had to try to figure out, well, what are we going to test? How can we test it? The idea of adding Android to our test mix, and Android is actually much more difficult to test because there's so many different devices, different operating system versions. On iOS, you have somewhere between 12 and 20 different permutations. On Android, we did the calculation once, there were over 13,000 different permutations of devices and screen resolutions and all of that. We figured, okay, even if it's simplistic, we're going to need to add another 300 testers just to cover those areas. We weren't hiring. We weren't going to grow at that point. So, in fact, we didn't. But the unintended consequence of not actually going in there and not testing or not automating is Supercell actually released their first versions of their games on iPads. We weren't on iPads. They kicked our butt on iPads, and then they went to Android, and then they kicked our butt on Android, and we essentially ceded that portion of the market to them. In doing that, Farmville, which Zynga is known for, on mobile is called Heyday by Supercell. So we lost our first mover advantage. We gave up one of our most valuable brands. So our failure to automate in this case, because we weren't going to hire 300 people, I get that, but we could have invested in automation. So again, we chose not to do something that seemed to make sense. It wasn't a significant portion of the market. It was way too expensive to actually test on it. But in the end, a year later, we gave up over half of our market to a competitor, which I don't think is a very good idea. Big data and machine learning. This is about 2 years ago. This is kind of an interesting side effect as well. Knowing what you want and don't want is key with machine learning, artificial intelligence, a lot of the big data analytics that people are using. We observed that players who purchase more often retain better in the games. So the more often you purchase, it correlates very strongly with people coming back and playing the games more. We wanted to optimize, therefore, for increasing the number of purchases. People purchase more, they play longer, they'll purchase more, they'll play more. It's just a nice virtuous loop. The problem is you have to be careful what you wish for. We actually saw a 5x increase in the number of orders. So it was amazingly successful from that perspective. The unintended consequence was we actually saw a pretty dramatic decrease in revenue. I go, well, how's that possible? Because we had a bunch of people who every day, every other day, would spend $100 once. And the machine learning algorithm optimized so that they would buy 5 times at $10. Well, 5 times 10 is 50. I'd rather have $100 once than $10 5 times. Now, the good news was we were very well versed in multivariate testing. This was in a tiny cohort, so we actually realized, yeah, we need to tune the algorithm. That's the wrong one. It does the right thing in terms of the order increase. It doesn't do the right thing in terms of revenue. So you have to understand, with machine learning, if you aren't careful, you might actually ruin your product. And if you do it in a fully automated fashion, you can ruin your product very quickly, all with all the big buzzwords around big data, deep learning, AI, et cetera. So it's really important to understand those consequences and hopefully avoid them. If you have an experimentation system, an A/B testing system, roll things out slowly, learn from your data as you go, have the ability to roll things back. Marketing resurrection campaign. This is 30 years ago, so I've been learning these lessons in data for a very, very long time. I worked for an investment management firm in 1987. The big stock market crash in October of 1987. I actually lost my job. I was a marketing analyst, but they said, you seem to be good with data and computer systems. We'll give you a job over in the IS or IT department. I said, great, I keep my job. Well, you don't keep that job, you get this job. Cool. We lost about 40% of funds under management. A mutual fund investment company makes its money by charging a percentage of the dollars they manage. So overnight, we lost 40% of our revenue. I was still reporting to the VP of marketing. He was very interested in figuring out how to resurrect old prospects. Those are people who had expressed an interest in our products, but they may never have actually purchased any of our mutual funds. We had over 250,000 prior addresses of prospects, which back in 1987, 250,000 records in a table was huge. They were in 3 different data formats, 3 different systems, and he said, I want to do a mailing to those 250,000 people, and I'm willing to pay the return postage just to get their new address, if that's what it takes. Well, I spent a week figuring out first just how do I even find a device to read this bizarre storage cartridge, and then I had to extract the data, normalize the data, finally did the mailing. It cost $1.50 in US dollars to send this piece out. It cost $1.50 for every piece that came back. We had a less than 1% valid email address, 3%. I remember what I put here. Yeah, 0.3% were still valid addresses. So most of this was just complete garbage. 750, 0.3% of 200, 750 valid addresses. Yay! The cost of postage times 3, $750,000 to do this. Essentially all the data was garbage. I'm rounding here. The cost per valid address was 1%. This slide didn't convert very well. The conversion rate on our marketing campaigns to actual customers was less than 1%. So less than 1% of all of this meant there were 7 to 8 people who converted, which meant the conversion of those 7 to 8 customers cost about $100,000 a piece, and that didn't even count for the week of my time. So again, not really thinking these things through. What we should have done is run a test. Grab 100 addresses, grab 1,000 addresses, do a mailing and see how many of them bounce, and extrapolate how much it's going to cost. The other thing is the marketing guy just wanted to be able to tell people we were doing everything we possibly could to grow our customer base again. It was a great story to be able to say, we've got 250,000 people who've expressed interest in our products. We're going to reach out to them. We're going to get them back in. Like, he didn't tell this story to his boss after the fact. This was a complete and utter waste of money. Yeah, these slides didn't convert well. I apologize. But data is expensive. Quick story. Technorati, this was 10 years ago, a blog search engine. We started really when the blogosphere was, I think, less than 1 million blogs, or maybe it was even less than 100,000 blogs when I started there. By the time I left, we had tens of millions, maybe even hundreds of millions of blogs indexed. So we really had the only fully indexed history of the blogosphere. Our CEO is incredibly proud of it. We were a 30-person company. We grew to, I think, as many as 60 people. Then I got to fire a bunch of people. And at the end, we were adding about $200,000 worth of disk space every quarter. For a tiny 30-person startup where I have to fire people, $200,000 every quarter is 2 engineers a quarter, the equivalent. So I can calculate how quickly there won't be anybody left at this company. We won't be able to make payroll. I actually got empowered by the board to go in and give the CEO the bad news that we were not going to keep all of this data forever. And he's like, but it's the only archive, it's huge, it's valuable. It's like, you never funded our ability to archive it in a different storage subsystem. This is the only way we know how to do it, and we can't actually keep spending this money. We don't have it. And the board told me to tell you we're going to start truncating data. So we started throwing it away, which is unfortunate because it was interesting data, but it actually saved the company. So that's another good idea here. So we had a different example is at Zynga. Again, this idea of, well, I'm writing something now, it's a small app, and I don't want to spend all this time thinking about all those other things. I just need to get this out. I've got a demo day. I've got to get my first prototype. I've got to get my first customer. I'm not going to think about data archive, data storage. Storage is cheap, right? No, I already said it's not. So what are you going to do about it? The thing is to think about if what you're doing right now isn't going to succeed, why are you doing it? If it is going to succeed, you're going to have a lot of data. Figure out a way to separate your data and build a minimal amount of infrastructure or even just metadata so you can move data out of the way. Compute is expensive. Trying to manage all of the players for Farmville in a real-time, low-latency, three-tiered architecture without the ability to back out the people who aren't playing anymore is really, really expensive. Farmville has over 500 million people who have ever installed the game. It probably has less than 100,000 active players right now. So it has a single architecture. So they actually have an in-memory representation of 500 million players, most of whom will never play the game again. Now, luckily, about 2 years ago, they implemented a model where they could start to shuffle things off to low-cost storage. But we actually built that game, scaled it out to keep everything there at the ready, just in case somebody who we already knew was never going to come play the game again came to play the game again. It'd be like having a giant mansion in the UK, big castle. You've got 50 people on staff to keep the linens pressed and everything's washed and everything's always there for the lord and lady in case they show up a minute from now. And they're both dead. They're never coming back. But you just keep paying all of these people to take care of the linens and the clothing and everything's perfect. Because that's kind of what we did. So the lesson there is make sure you have a way of getting the data out of your way when you don't need it anymore. Put it in low-cost storage, shove it into Amazon Glacier, put it on something else, but don't avoid the code and the logic necessary to move it out of your way, because it will bite you hard. We built 4 data centers, 12.5 megawatts worth of storage, hundreds of millions of dollars later because of stupid things like this. We never needed to do it. Postini. Postini was an email spam antivirus filtering kind of a SaaS product before SaaS was even an acronym. This is a good story. This is about 15 years ago. We actually had technology. We would rip emails apart and build these giant corpora of emails to understand all of the different things that might indicate this message is spam. And the really interesting piece was statistically, we could extract something like 4,000 different attributes from a message and say, if these things are on, then there's a high probability it's spam. Every message might have different sort of features or signals that are on. But what we did was we also said, what is the probability that something is not spam? It turns out there's a whole different set of features that are indicative of something not being spam. And so in terms of these charts, in the first one, the simplistic one is you sort of have these even distributions of all of your email. Everything that's not spam scores really low, 0, it's not spam. The higher the score, closer to 1, the higher probability it's spam. But you draw a line right down the middle. If this is really an even distribution, you might as well just flip a coin. Half the time you're right, half the time you're wrong. What we tried to do is statistically is push these curves to the extremes so that we could actually train the system to say the chance of a false positive of calling something spam that isn't diminishes as I push that curve that way. Similarly, the chance of letting spam through, even though it's this piece of spam, I'm going to say it's not spam. What became really simple is this is just an easy mathematical comparison. And at runtime, we could allow customers to simply move that slider back and forth. What's your tolerance for false positives, where we take an action on something that's not actually spam, that people don't like that? Or how much excess spam are you willing to tolerate because you're really not willing to tolerate the false positives? So again, a really simple trick of just evaluating those probabilities at the same time and then just picking. And it became very, very simple. Customers were ultimately very happy about that. They were able to understand what we were doing. They hated the fact that we couldn't just identify all the spam and we couldn't just recognize everything that was legitimate. But if I receive an email from somebody who's never sent me an email before that says, "Hi, Mom," okay, but how's the algorithm going to know I've never received email from that person before? It's ridiculous that it would think I'm their mom, but it's just 2 words. What's it supposed to do? One of the other things that we did, and this kind of goes back to that aspect of understanding context and experience, the context is really important. And the experience, we were able to capture statistics over time. So we could actually say, this is the first time you've ever received email from that address. That's suspicious, because you receive email from the same people all the time. Short email messages are particularly difficult. There's just not enough context. So in that case, we might say, you know what, I'm going to let it through. The risk of calling it spam is too high. Because if it really is, if I'm really that person's mom, we don't want to be blocking that message. But if that sending email server is sending email to a whole bunch of mailboxes that we're protecting, and they're all with these really short messages, and we've seen a bunch of these things, and it's increased dramatically over the last hour, it's a spam attack. So adding the context and the experience, seeing the data over time, completely changes our ability to make a good call, and we can start blocking all of that stuff. So actually, that's what we ended up doing. We got some patents on it, and we built some products that allowed us to actually look at aggregations of information over time, as well as what we call the transport heuristics. Where's it coming from? How frequently is it being sent? Aspects that have nothing to do with the actual content of the message. Mafia Wars, even failure can teach you. This is about 7 years ago. Mafia Wars had a classic 3-tiered architecture, Memcache, a bunch of web servers in front of Memcache, Memcache in front of a relational database. Let's say we had a big Memcache pool of our player data, and it has 100 nodes in it. Well, if one node fails, well, you think, well, it's an even distribution using some hashing algorithm. 1% of the players can't play, right? Wrong. What we found out was because I'm playing in my Mafia, I'm fighting somebody else, right away, even if I can play, the person I'm trying to fight might actually be in that one shard, that one Memcache that's down. That's not good. So now I can't play because the person I want to fight isn't loadable. The other one is, in order to bring all of my friends to my fight, I want to fetch their player blobs. And now if I have 100 friends, there's a good chance one of my friends is in that shard. So now either the person I'm trying to fight is in that shard and I'm not going to be able to get it, or somebody I need to help me go kick this guy's butt is in that shard and now I can't. Our coders weren't particularly defensive in their coding, so that kind of a Memcache lookup failure with a host being down would just kill the PHP process. So you wouldn't even get an error message, you just get a white screen of death. I don't know if anybody's written code in PHP, but when PHP barfs, web server chokes, you get nothing except the white screen of death. So the lesson learned here was the distribution was not what we really thought it would be. It wasn't just, oh, one node out of 100, it's 1%. It was up to 60% of our players were impacted by one node going down. So we had to get a lot more defensive in our coding. That was good because I was trying to convince developers to be more defensive in their coding. This was hard evidence to help them do that. This one I'll go through quickly. This is sort of my own theory. So exponential growth, viral growth, everybody wants that, particularly in social apps. I think a big part of the story about Zynga is we had this explosive and I think symbiotic relationship with Facebook. We did incredibly well. We created a very dense gaming social graph kind of on Facebook's back. We had these amazingly powerful super nodes that brought lots of other people in Mafia Wars. They were called, the Godfathers. Interesting fact was more of the Godfathers in Mafia Wars, the people who really brought everybody together, were women. So they were actually godmothers. And when those people stopped playing, the game collapsed. So on the other side of exponential growth is exponential decay. And you might say, oh, well, we've only lost 5,000 players. But which 5,000? Those 5,000 could actually be connected to the lifeblood of your app, your product. So I think it's important to understand, measure the growth of the nodes in your graph, measure the growth of the connections in those graphs, try to understand the freshness, how recent have these things been connected. It's not a one-time thing. Are they still playing together? Is there something that's keeping them active? That's sort of your intensity, the frequency of interaction. Track the trends on those things and anticipate the collapse of your graph. Hopefully it doesn't happen to you, but there's a lot of information. You can't just say, I have this many daily active users, and so my game must be healthy. In a social game, you actually have to have a very strong underlying social graph. So that was an interesting piece. I don't know if this is actually true. I never got to do the actual analysis on the historical data, but this is my hypothesis. I'd love to do an experiment on it. Finally, multivariate testing, I think this is the last one. This is applicable for today. A/B or multivariate testing, you should all definitely be looking at it. If sometimes it's as simple as, do I say click here or enter here on my button? I don't know. You can just guess which one do you like better, which one's shorter, which one sounds better. It's like, put it in the test. Roll it out to 3% of your users. Record, do you get better click-through rate on click here or enter here? Do you get better click-through on search or find? It's just really simple textual things. But that means wrap your text in an experiment wrapper. Have a little function call, wrap your text, so you can actually dynamically swap text in and out and record what was the text that was displayed when that person clicked. Because if you don't record which variant you were running, you won't be able to do the analysis. So, but that little experiment trick and wrapping these things allows you to then run multiple variants if you want. A really nasty realization one of our PMs had last year was we have these giant population sets, 1 million people playing a game. We'll just do a hashing of the player ID, some big number, hash it, we get a relatively even distribution of everything. Well, we also have really strange distributions of certain types of players. So less than 3% of our players in a freemium-based game actually pay any money. Most everybody plays for free. But the idea is the more people you have, the more social it is, the more active it is, the better the engagement, the retention. You'll attract people that want to spend money. So it's okay, 3%. But less than 1% of that 3% are what you'd call whales or top spenders. So if we use this example where I've got 4 quadrants, and I've got a relatively even distribution of players across all those quadrants, A, B, C, and D, if I do a multivariate test, just assuming I'm going to get even distribution and therefore even behavior and analytics from this, I could make some really stupid decisions. Because it turns out that A has 1 top spender, C has 3, B has 3, and D has none. If I make D the control, those top spenders will make every test I run look like it's a winner. It generates a lot more revenue than the control. If I pick C as the control, B might be a contender, but I'm going to throw A and D out because the distribution of those anomalies is not an even distribution. This was something that we actually realized just last year. We've been doing multivariate testing, pretty well and sophisticated for over 8 years. We have a very sophisticated experiment management platform. PMs can just go to web pages and set experiments up. They can ship them without shipping any code. We can tie lots of different tests and things to these things. But this was something that caught everybody by surprise. The fix was actually pretty simple. The fix was just to throw the outliers out. So when you select your sample set across certain critical dimensions, throw the outliers out. Actually, more correctly, don't throw them out. Throw them out of your cohort analysis and then do detailed deep dives on the outliers to make sure that although variant B might be the most effective for the normal population, it kills top spenders. That would be a terrible thing to do. So you want to actually do both. And so that's what they did. They actually automated that, put that into the experimentation platform, and the experimentation platform just automatically did all of that, creating the right samples and the corrective work in the reporting system. And because everybody had just wrapped their code with a little experiment call, nobody had to rewrite any game code. So again, sort of some of these things people are like, oh, I'm going to do A/B testing later. The classic example of there, and I've told several people this today, is I'll do localization later. Like, don't do localization later. If you think you have to localize your product, just take a localization framework, do anything, wrap your calls, because going through hundreds of thousands of lines of user-facing content code later to try to extract your strings is so painful, most people won't ever do it, which means you'll never be localized. So just remember, insights and meaning come from the context and experience. Your context and experience not only will vary, it'll often be incomplete or just fundamentally wrong. Data is not information. My CSV is just data. You have to actually add your context and your experience to make that meaningful to you in some way. Data can be very expensive. Context can be wrong. So you might think you know what you're talking about, but you actually don't. Maybe that's me tonight. Challenge yourself to question. Always, even when you get those answers. So the machine learning piece, these answers here, but are there any unintended consequences? It took us a long time to actually question, because we had used the same algorithm to create our cohorts for 7 years. Like, oh, nobody ever asked, are there any unintended consequences for that? So always challenge yourself. I mean, I love questions. I love data. I love getting answers. The main reason I love getting answers is so I can ask new questions. So be curious and keep doing it. And that's it. Thank you very much. Happy to answer any questions if we have any time.
My question would be this. I deal in my previous jobs as well as my current job trying to get management to back certain decisions. So I think the beauty of data-driven development is that it seems like or a trap that a lot of people fall into is saying that, okay, because you have a certain set of data, they expect it to give answers. Like it's very rational, you have a number or a metric that looks really beautiful and easy to understand. And like the last sentence that you said, like it doesn't necessarily instill curiosity, but instead it kind of is used as a justification for really simplistic, simplistic assumptions. So when you communicate data, when you do A/B testing or any kind of studies, how do you, or is there for you a method of approaching management, approaching colleagues, and framing the discussion around data not in this very simplistic one kind of like direction of discussion, or do you have any kind of like method of instilling a debate rather than just looking for like that one simple answer?
Liz will probably laugh at this. My boss of 3 years ago coined a phrase. He called me ranty data guy. So my approach was to simply overwhelm people with so much data they would just break. They'd have to give in. Turns out it's not a very effective method, but I did it for a very long time in my career. I'm very passionate about data. I'm good with data. I'm good with numbers. I feel like given the data that I have and the experience that I have, I come up with right answers faster than most people, but it's just not, I wouldn't use that technique. But with that, what you can do is try to understand the things that people are looking for, and hopefully, what are the insights you either already have or the insights you can generate. And I think a lot of this comes back to an approach I take for just about everything in software development, in deriving features, and trying to figure out which partners. It's like, do an experiment. Can you get management to buy into a lightweight experiment? What is an experiment? Scientific method. Formulate a hypothesis. Ideally, define the criteria with very specific and simple, unambiguous, measurable aspects to say, this will be true if this is true, and this is true. Then construct an experiment, lightweight, hopefully, cheap, maybe it's a day, maybe it's an hour, maybe it's a week, whatever feels lightweight, on a data sample, on a sample set of users, in some way. And in the course of your experiment, have additional instrumentation and indicators to say, is my experiment still on track? And it might actually be that what you're instrumenting and what you're looking for aren't the same 3 things that prove your experiment is true or your hypothesis is true or not. They're just telling you, am I on course? Do I think like I'm getting there? And when you're not there, when you're starting to go off course, be honest with yourself and say, okay, am I going to fight as hard as I can to get back on course, or am I just going to abandon ship and call it a day? But I think that approach, the scientific method, making things unambiguous really helps. If you work with a management team that's unwilling to invest in experimentation, maybe find another job, I don't know, but it seems like trying things out is a really important way to learn, and learning is only going to happen when you make a lot of mistakes. I've made a ton of mistakes. I've made almost all of these mistakes. That's why I've learned from them. That's why I don't make those mistakes anymore. Now I make new mistakes. But it's really important for people to understand, give me a chance to prove a hypothesis. Break something down into smaller pieces and say, well, if I can prove this one thing to you, will you fund the next 5? Yes? No? What would it take for me to prove this one thing to you? And then if I do that, are you on board? And then we'll do the next 5. So the key lesson there is, given any big problem, you can break it down into n smaller problems, but recognize you've created at least n+1 problems because you have to put them all back together again. And it's usually harder than just once. If you've ever taken a motorcycle apart, You find that piece at the end going, I wonder what this does. Like, sometimes you have to be paying attention to those. Did I answer it?
Yeah, okay. Thanks.
So my question is related to like games and how you develop games based on data. So like games are at the end are just an entertainment tool, but today with all the data-driven approach, we can actually create games that are very, very locking in the users. And where does a game actually loses being a game and then just an addiction machine? And can actually like a machine learning algorithm just create similar like products where there is no human ID needed for a game, because it's all about just locking in someone into a constant spiral of buying, improving,
right.
XP and these things, because that's sort of my feeling that's the direction that we are getting with some of the games, that there is no big idea behind it. It's just really made for keeping people in as long as possible and then dump.
Well, so there are a couple of parts to that. One, there's actually a ton of applicable behavioral science to game development and sort of the aspects of addiction. You might call them compulsion. There are aspects to sort of what's called completionism. Oh, I only have 3 of 5 things completed. I feel compelled to finish this. Leaderboards, I want to be at the top of the leaderboard. So there are lots of behavioral science aspects to humans that you could probably codify, and maybe some software out there could be written to figure out the right way to do those things, and maybe someone will even write AI that will figure out how to write that software. I don't know how to do that. I don't know when that might be done. I don't know if that'll ever be done. But there are really interesting things that are happening in games today. It's been happening for several years. And a simple example, and I don't know if they actually do this. This could all just be myth. But in a game like Candy Crush, there's an aspect of level difficulty, and that level difficulty can be tuned, and it can actually be tuned dynamically. So you might be playing this level, and you've been playing every day for 3 days. You've been trying to beat this level. It's the 70th time. They can actually make the level easier, and they can do some of that just to give you that, oh, I almost there, because when it's just hard, you quit. And in fact, they have data that shows when it's so hard that you can't get past it, you quit. They want to make it a little bit easier, give you a little bit of a freebie, and then, so with static tuning, they kind of give everybody the same experience. Some people blow through it. It's not fun because it's not hard enough. I always win every level. I'm at level 100. It's not even, it's dumb. So you stop playing the game. They don't want that either. They also want to know this person is moving too quickly through the game. So they make it harder. Now, I don't know whether they're doing that dynamically. I don't think it's AI in the binary on your phone. I'm not sure if they're making network round trips to try to get new level tuning. I don't know if they're storing some data in the player's data set to say make it a little harder, make sure they can get past this level after 3 tries, whatever it might be. But there is a feedback loop. And that feedback loop is going through big data. And it's both in terms of clustering. People who play like this and exhibit these types of patterns quit. If we can tweak them before they quit, we can do this. So that happens. I do know this one. Supercell actually has bots. Now, they use them for development because they also do a lot of on-the-fly dynamic tuning in terms of battle situations, simulations, who's fighting against whom. They use it for testing purposes, just to exercise all the different possibilities. But they also use it to understand the dynamic nature of the game, because sometimes the kind of gameplay you as one player might want when you're attacking another player, they don't have a player like that. So they might synthesize that player. So there is AI, or even maybe just machine learning, that is happening on the back end, and it's probably happening asynchronously. It's not synchronous in process in the app, but the machines, the tuning is happening and is changing the gameplay. So everybody's gameplay can actually be not just personalized, but tailored to their tolerance and, under the hood, their sort of psychographic profile. People have been doing this in advertising for 20 years. I mean, I worked on a psychographic profiling and targeting engine 20 years ago. So, I mean, it can be done. It has been done. We were reading a really scary article about this company, Cambridge Analytica, which supposedly the Trump campaign had actually engaged to do a lot of micro-targeting on Facebook users. And they actually used certain stories, at that point it was called fake news, to manipulate those people to get them to believe things, to either show up to vote or get them to say, there's no point in voting, I don't want it. And so they use that in very micro-targeted ways to change the outcomes in critical counties. And that is, in my view, insidious and brilliant at the same time. And one of the simple tools they used was Facebook surveys. You know all those stupid surveys? What kind of a cat are you? What kind of musician are you? What kind of band are you? They targeted those things to actually glean more data than they could scrape likes, scrape other things from people to find out what are you paying attention to and how are you doing that. Build a psychographic profile and figure out these people in these key geographies are susceptible to this kind of a message. But they wouldn't always know, so they would set up an experiment and they'd say, we have 100 people, we think they're targetable with this kind of a message. How well does it work? And then they would lather, rinse, repeat. They would just do iterative programming. They would do multivariate testing. It's just creepy as all. I'll leave the expletive out. So we're not there yet, I don't think, but we may be closer than we think. And it could be really, really scary. It could also be really fun. It's just you guys have to do it. Then it's going to be awesome, right? Any other questions? All right, we'll leave on that note. Thank you, everybody.
Thank you. Que la famille.